So I'm going to create a project, a new sample project, and I'll be showing you uh, the how to add the libraries and how to start coding. So before getting into details, who are not from Java background, so what is a build path and what is a project, I want to explain. So when you open your Eclipse tool, when you open Eclipse tool, your Eclipse tool is designed based on the Java. So your Eclipse tool is nothing but a Java project. Eclipse tool is designed or developed using Java. So what your Eclipse tool will do, it easily recognizes what is the no Java installed in your system, and it can easily recognize those libraries automatically. Okay, so everyone right click and create a project. Everyone right click and create a project. Suprit, you, Suprit and Madhu, Debashish. Debashish, are you there?
Yes, Ravi. Hello.
Please, yeah. Open
Yes,
the
Ravi.
open your Eclipse. The right click on the left pane and just type right click Java project and just take a project. So it asks you to which JRE environment, which Java runtime environment you want to take, and it will ask you just, it will be there by default configuration based on the version you have installed in your machine. Just finish it. Just finish it. Is everyone is created project? Supriti created project? Suprit, do you created a project? Madhu, Debashish. Suprit, Madhu, Debashish, please tell me whether you guys created or not.
Yeah, I'm creating.
I'm
Yes, Ravi. Great.
I just downloaded the Eclipse and extracted in a VM.
No, it was there before, right? When we are going for Java project, when we are doing a Java programs.
I did not do that. I did not attend the Java classes because I'm still from Java, right? So I'm just doing that right now. That's okay.
Okay, then you can view the video later to do this. So after creating the Java, when you expand this project, then you will see there is a JRE system libraries which automatically comes as soon as you create a Java project in Eclipse. So these jar files or these JRE libraries will help you to code Java or core Java applications. I mean core Java code, right? So if you want to write a code for any third-party library or any third-party framework like a servlets, JSP or Hibernate, Spring, Struts, any third-party, Mapreduce, any other frameworks, because your Eclipse is not aware of those frameworks. Your Eclipse is aware only the JRE libraries. Like as soon as you create a project, Java project, it will bring all the Java which is required for the Java, those jar files it will bring it automatically. But when you want to code on your serverless JSPs, or you want to code on any other framework, Hibernate, Spring or MapReduce, any other JSF or whatever it is, okay, you need to tell to your Eclipse, or you need to tell to your project, these are the jar files are required to code other third-party frameworks. Okay, now how we will tell? We will tell to our project by using build path. Build path is nothing but build path is nothing but your project will be keep compiling. Your project will be compiling internally. Okay, as soon as you code, as soon as you save, the code will compile. How it will compile? How automatically it will compile? When you see in Eclipse tool, there is some folder, some tab called project. Click on the project. There is something build automatically. Build automatically. So that will be a by default it's checked, or if you didn't check also, it will. If you are not check, what will happen? It will wait till you finish the all your code. Then you have to do clean, or you have to build it manually. You have to build it manually. So so your project, when you're compiling your project, so you can easily code. Okay, we can write the code and all. After while compiling, it has to use some jar files. Let's say if I say here mapper, let's say if I do here mapper, I did mapper here. Your Eclipse doesn't know what is mapper. When I compile this code, that project should understand, okay, mapper is coming from some third-party framework. I need to use the jar file to compile. So where is the jar file to use? That jar file is, we will keep in a build path. That is a build path. Build path is nothing but, suppose if you want to use any third-party classes or predefined classes or interfaces, what abstract classes or interfaces, which is given by a framework. So when you are writing a code in the using those frameworks, while compiling, it needs to use those class files. So how will I use? Until unless if you give me a jar file, then only I can use. If you didn't give me a jar file, I cannot use. So we need, when you create a project along with your third party, when you create a project for the third party frameworks, you need to add the jar files for that build path, that project. So while compiling it, while building is nothing but compiling, or compiling and running. So while doing that, it will make use of that jar file. Okay. So Eclipse is given a way to add the jar files. That's called, right click on your project, go to build path, configure build path. Click on configure build path. As soon as you click on the configure build path, you will get this page. And there is something called order and exports. There is something called libraries, projects, and resources. Okay. So in the libraries, you'll be having a default JRE library. Default JRE library. So here I would like to tell you a little a small example. So now what we can do, libraries are required. You can directly add the jar files. If you click on this add jar files, in the current existing projects in your Eclipse, you can add the jar files from there. But I don't want to do that. And add external jars. You can add the external jars from your from where your third party software installed. From there you can get the jar files. So that's the other way. So in this Eclipse, you can add the jar files individually. Individual jar files you can add here. Individual jar files you can add here. So let's look at, I want to show you a little small thing, that is, okay, let's guys look at here. I have something called my Mapreduce framework. Because I'm taking a Mapreduce as example. Okay, I have something called my Mapreduce framework, MR framework it is, and I have some Eclipse here. I have something, my environment. Eclipse in the sense my coding environment where I'm going to write my code. This is my environment. So I have created project one. I have created project one. So here I have libraries. jar 1, jar 2, jar 3 and so on. Jar means Java archive file. Jar means Java archive file which contains the all compiled code of Java. Like all class files will contain the jar files. All class files will contain this. So now I have created. This is my Eclipse. This is my Eclipse, and this is project one I have created. So when I create a project one, I need a third-party libraries. I need to add this jar. 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 Okay, now my project will compile successfully. I can execute. I can finish my work. So I have created project 2. I have created project 2. That's also Mapreduce project. I need to add again these all jar files. I need to add all the jar files again for this project 2 also. I need to put the same effort what I have you put the effort for the project 1. I need to put the same effort for the project 2 also. If I go with the project 3, I need to put the same effort for the same. So instead of that, what I say, we will create a layer between these two. The layer between these two. The project 1 and project 2 are in between this map region. That layer is, I'll create one layer here. That is called user library. User library. What is this user library? I'll create one user library. I'll add all the jars to this. I'll add all the jars to this. So whenever I create a project from the Eclipse, I'll just point to this. So second time I create a project, I'll just add to this. Third time I create a project, I'll add to this. Fifth time I create a project, I'll add to this. So any number of times you create a project, you just need to add the user library. That's the advantage of creating a user library. So we are going to do now, create a user library. In the Eclipse tool, we are going to create user library. How to create user library? Click here, add library, select user library. Everyone guys, please follow the my screens. So please right click, build path, in that libraries, add library, select user library. Select user library. After selecting user library, next. When you create a user library, in your case it will be empty, but in my case I have already created. In your case it will be empty. In your case it will be empty. Click on the user libraries. Click on the user libraries. Click on the user libraries. You'll be having other screen. You have to click on the user libraries. You have to click on the user libraries. After clicking on the user library, you will get a window of user libraries window. So in your case, if you want to create a new one, create new one. Create new one. Is everyone in the same page? Supreet, Sunil, Srini,
Yes, Ravi.
Devashish, everyone in the same page, right? Supreet?
Yes, Ravi.
Ravi, we have followed that video. I have done it already.
You had a very good. Then good.
Yeah, you have shared that video, right? Last week. I
Correct.
followed the same thing. Yeah.
Okay. So now you need to give something called a name for it. Something called a name for it. So just click OK. This is nothing but a directory, guys. This is nothing but a small directory which is already, you are creating a directory. You're putting all the necessary jars into the directory. As simple as that. Instead of doing other way, we are doing through a tool. That's it. That's the only difference. So select this user library. What are the library you have created? Click on add external jars. Here also same. You can create new means new library you're creating. Edit means your existing one you will edit the library user library. Add jars means from the current project. Import means if already there you can import. Export means you can export. Okay. You add external jars. Click on the add external jars. You need to download. Now you need to add all the jar files. Okay. Supreet, which step you are in?
I got disconnected. I will do it after I'll watch and rewatch and do it. You can just proceed further.
Okay. So go to Hadoop, and in that you will be having something called share. In that you have something called doc and Hadoop. Doc is for the documentation like your default XML files. There is something, your Hadoop home, in your case is a Hadoop-env inside the Hadoop 2.6.4. That's in our case. Okay, go to share directory, go to your Hadoop, and in here you will see some of the libraries. Some of the already some folders are there. Some folders are there. In this folder, so what my suggestion is here, in the normal cases in the real time, you don't need all these jar files. You don't need you don't need all these jar files. You need only Hadoop common, Hadoop core, Hadoop common, Hadoop core. Hardly 3-4 jar files are required. But we are adding all the jar files from here. Whatever is there in the Hadoop share and HDFS, let's say I go with the HDFS first. So all these 3 jar files I'll add. This 3 jar files I'll add. First, I'll add these 3 jar files. Again, I need to select this. Whenever I select, then only it will be enabled. Let's say if I clicked on here, so this is not enabled. You cannot select. You cannot add. So whenever I want to add, I have to select this. Go again, and in the HDFS, again I'm adding all these libraries. Why I'm adding all the libraries? Today, see, you need to add only 3-4 libraries. In the real time also you'll add only 3-4 libraries. But tomorrow you may want to connect your you want to code for HDFS in Java, and you want to connect your HDFS with a servlet or a JSP, or you want to connect with uh, your project with some other related things like see, if we see here some of the tools, some of the some of the tools you want to connect. So when you want to write a code for it, we have to add all the jars that time. So instead of adding all the tools that time, we will add all the jars now only into the user library. We'll make use of it. But for the real time, we won't need all these jar. So we won't need all these jar. If you take this example, what I have already created, there are so many jar files. There are so many jar files. These many jar files are not required, guys. Frankly speaking, these many jar files are not required. Why it is not required? Because we are not going to use all these libraries in our real-time project. The real-time project will be using your Hadoop core, Hadoop common, logging. These are a few little jars only we will be using the real time. We need only those jar files. Why we need to add all these jar files into why we not add all the jar files into real time? Because when you add all the jar files, let's say I think almost here I have more than 50 jar files are there. 50 to 60 jar files are there. If I add all these 50 to 60 jar files in my project size will become more. My project size will increase more. Okay, my project size will increase more. What will happen if size is increase more? Your project size will increase more, and it will take so much of time. If you're building through Ant, or if you're building through any of the third-party libraries like Maven, or if you're building through your Jenkins, it will take so much of time in the real time. That's why we'll try to minimize in the real-time projects, we'll use only required jars. We'll not add unnecessary jars in the real-time project. We'll not add unnecessary jars in the real time. Why? To reduce the build time, to reduce the size of the project. Okay, now so that's, but here I'm adding for the practice purpose all the jar files. Tomorrow I may write some code for serverless, some code for JSP, some code for I want to interact with the HDFS using Java. So these kind of things I may do in the future. So that's why I kept everything in the user library ready. That time I no need to worry. So just go ahead and connect to user library. I can finish up the things. So after you create this, click on OK. You need to click on OK. When you click on OK, it will be it will ask you to select one of that. You can select again, finish. As soon as you finish, that will be available here in your libraries and your project libraries it is. So then click OK. As soon as you click OK here, under your project, you will see two jar files. I mean two set of libraries, user libraries. This is one library, this is one library. Initially it was only one library, if you remember. This is now two libraries are there. Okay, now my libraries are ready in my project. I just need to go ahead and code. I just need to go ahead and code. I just need to go ahead and code. Understand guys why I have added all this? Why I have added this? Okay, any doubt please let me know. So I will explain this and I will explain one more time and I'll take you to the programs. Is this clear why I have created this much? Sulba, all other guys. Is this clear? Sulba, Supreet,
Yes.
Srini, Matsudan,
Yep.
Anila. Okay, let's go ahead and go ahead and write here what we need to do. Right click. First we'll create some package. So you can create any package. It no need to start with the com, but so most of the real-time projects will start with the com. So mr.jobs. Or if you want to create one package for one projects, like I say word count. I'm going to show you as a simple example which we will be seeing in the most of the blogs and here and there. We'll be taking the same example and we will be explaining that. First let me explain you the how word count program works, and later I will take you into the code. Let's say small data set. Let's assume that this is a one data set. Data set is nothing but the data which you are going to use. That's called, we'll call that as a data set. Okay, this, let's assume that this is my data set. Now I'm going to count the words, which are the words are repeated, how many times it is repeated. That I'm going to show you here now. Okay, as soon as you as soon as you as soon as you take the data set, first what are the things we need to consider? First we need to understand the data set. First we need to understand the date requirement. What is the requirement? Requirement is word count. I want to count the words. Word, how many times the word is repeated. That's the requirement. The second one, we need to understand, the first one is we need to understand the requirement. Second one, we need to understand the data. Until unless you understand the data, you cannot design your code. Understand the data. Understanding the data means type of data, whether it's a structured data or unstructured data or semi-structured data, what is the type of data and what is the format of the data, and whether it's a text, whether it's a text data or whether it is a what, and what is a delimiter, what is a delimiter, what is a delimiter. We need to understand about the data first. We need to understand the data first. So next step is, the step 3 is, once you understand the data, we need to, the third one is, if it is a text type data, what is the input format I need to take? What is the input format I would need to consider? You need to understand your input type, your input format. You need to take a input format. So based on the data. So if it is a text data, I will go with the text input format. If it is a sequence data, I will go with the sequence file. If it is a database related data, I will go with the database DB input format. Okay, so you need to understand this. So once you decided what is your input format, then you need to understand what is the key in. So in my terms, K1, and what is value in. What is the key in, what is the value in? Because you will map will, as we discussed yesterday, your mapper will take a key and value, and it will give you key and value, right? So we need to understand what is the key in, what is the value in. So that is based on the your input format. Let's say an example, we are taking the text input format. My key is offset. So I'm repeating what is the offset one more time. The offset is it will start with 0. The offset is something called, we start with 0, 0, 1, 2, 3, 4, 5, and so on, so on. The number of characters in that line till it is a /n, till it's find the /n. So that is a starting offset of that line and number of characters. Let's assume that here I have a 15 characters. So next line will start with a 16, 16, 17, 18, 19, and so on. So the offset is that. What type of offset it is? I mean, what type of this is key. So now I'm using the, if I'm using the text input format, key will be offset, value will be the complete line. Value will be complete line. This complete line is the value. It'll, who will divide this? Your input format will divide this. You no need to worry about it. Your input format will take care of it. You no need to worry about it. First thing, what is the input format I have to take? You said this, you should decide it. Once you decide it, the key and value will be taken by your framework. Key and value will be taken by your framework. So my key is here. When I come to here, my key is number type. My key is number type. My value is text type. What is the type of your K1 V1? You need to decide. If it is a number type, we have something called in a, if it is a number type, we have something called in a data types are there in a Hadoop. So if it is number type, I have to go with either int writable or long writable. What is the int writable, long writable? These are the data types. We didn't discuss about the data types, guys.
Yes, we have discussed, Ravi.
That was a Saturday class, or we discussed on
Saturday it seems. Long writable, int writable, text, and all we have
it was
discussed.
Saturday class. Then I need to discuss now. Okay, and value is a text. Okay, so let me discuss about the data types, guys, then I'll take you into here. So otherwise, if I didn't discuss about the data types, I thought I have already discussed about the data types. That's wrong. Okay, first I need to understand that. So whenever you get a problem statement, this is what I have. First we need to understand the data. First you need to understand the requirement, data, then input format, then what is your K1 V1, what is your K2 V2. I'll explain this now. So I will be having somewhere here. Yep, here. So okay. So we have seen your map will take a K1 V1. Yesterday everyone we have seen this one. That is for sure. Yesterday we have seen map will take a key in, value in, and will give you key out, key out, value out. Right? This is what we have seen last class also yesterday. So your mapper will take this part, like it will take a key value and gives you key value, context dot write K2 V2. And that K2 V2, the mapper output is nothing but input your reducer. Your reducer also work on the K2 V2, and final output will be K3 V3. Okay. this is what we have seen yesterday. I think everyone is clear about the Mapreduce framework. Your mapper will take a key and value and gives you a key and value. Your reducer also will take a key and value and gives you the key and value. So whatever it is taking as input from the your text file or whatever the data you are giving, it will take the key and value. It will convert into key. Internally it will get converted into key value. Who will convert? I'll tell you. Internally it will convert the key and value, and it will gives you a key and value as output from the mapper side. From the mapper side, and whatever is the mapper output, that is input to your reducer. That is input to your reducer. Reducer does not have a different type of input apart from your mapper output. Let's say my mapper output is giving integer comma integer. I mean key also integer, value also integer. Your reducer input should be integer and integer type. It should not have a different type. If it has a different type, the program will fail. It will not execute. So very simple. Your mapper will take a key and value. Your reducer also will take a key and value to process the data. Any type of data, so forget about it. Even the binary data, even though it is any type of data, your Mapreduce framework believes that you give me key and value, I'll take it as a key value and it'll give you as a key value. Okay, so you in the sense not you, so not the data. Data can be any type of data. Internally, the Mapreduce framework converts based on the data input format. Based on the input format, your record reader will decide what is the key and what is the value. We know what is a record reader. Record reader is a class or who tells you how to read the data from the input split. How to read the data from the input split. Record reader is the one who will tell you how to read the data from the input split. So your record reader will divide what is my key, what is my value. What is my key, what is my value, right? So when you take this key and value, they will be having some data type, no? Let's say if I take a add method, let's say I take a simple add method. Let's say if I simply take an add method, normally Java add method. I'm saying int I comma int j. I'm specifying what is the type of my I value, j value, right? Inside the add method, the same the same way your map method also, you are defining key and value, you have to type what type of key it is, what is the type of this. So Hadoop also has its own data types. Hadoop has its own data types. When it comes to Java, it is int and integer. Int is a primitive type, integer is a wrapper class. Int is a primitive, integer is a wrapper class. That has been converted into int writable. And you have something called float and float wrapper class. That is into Hadoop is a float writable. And you have something called double and double in a Java. That has been converted, that has been in Java, in the Hadoop it is, in the Mapreduce framework it is double writable. Double writable. In Java we have something called long and long, but when it comes to Hadoop we have a long writable. We have something called character array or string in a Java. Here text. We have something called null. Null is not a data type in Java, but it is a value in Java. Null is a value in Java. So that value also has some type that is null writable in Hadoop. You have something called Boolean. Boolean in Java, or not only Java, any language you take, C or Java, C++. Okay. So Boolean, here it is a Boolean writable. There is something called one more map writable in Hadoop that we will talk later. Map writable. Is everyone is clear about the data types? Hadoop also has its own data types. It is not going to use the Java own data types. Hadoop does not have a primitive data types. Hadoop does not have a primitive data types. Hadoop does not have a primitive data types. Hadoop has everything as a classes, objects. Int writable is an object. As a class actually will create object for it. Float writable is object. Double writable is an object. Long writable it's an object. Text it is an object. Null writable it's an object. So Boolean writable it's an object. Map writable, it's an object. Everything in Hadoop is an object. It's not, there is no primitive data types in the Mapreduce framework. Why? These are all by default serializable. What is the serialization, guys? And whoever attended the Java classes, they might have known it. What is the serialization? So that here in Hadoop, the data will be transferring, the data will be going through network, right? It will go to map route, it will go to the mapper. Mapper will, the data traverse through a network, and mapper will give output. That data will be traversed through some network and it will go to a reducer. It means your data is traveling one machine to another machine. When the data is traveling one machine to another machine in the form of objects, objects cannot travel directly. Those things has to be converted into byte stream. The converting object from to byte stream is nothing but serialization. Serialization is nothing but a converting your object into byte stream, converting your object state, converting your object variables, converting your object values, variable values into byte stream is nothing but a serialization in Java. Okay, so not only Java, everywhere the serialization means that only. Okay, so when it comes to Hadoop, by default your int writable, float writable, double writable, long writable, and so on, they are serializable, by default serializable. Like how you have an in Java integer, float, double, long, string. They also, integer is a class, float is a class, double is a class. These are all wrapper classes. Those are already by default serializable. Those are by default serializable. But the technique which has used in Java, the serialization is different. The technique what is used in Hadoop, the serialization is different. In Hadoop, the serialization they have used, the serialization will take less amount of the space. It will occupy the less amount of the process. And in Java, there's a very big number which will take the huge space. Okay, so that's why Hadoop come up with, because it's we are going to deal with big data, so I don't want to waste the memory size. I don't want to keep this into RAM memory for long numbers, a long serializable code, or it's called serialization ID. So I don't want to keep that much long ID into RAM memory. So that's why Hadoop come up with its own serializable process that's called writable. That's called writable and comparable. So uh, that's why Hadoop has its own data types. Is everyone is clear about the data types? Is everyone is clear about the data types?
Yes, sir.
Anila, Debashish, who are not from the Java background, who are not from the programming background.
Yes, Ravi. Clear.
Okay. Raghu.
Yes, sir.
Okay. Thank you guys. Then you know you have a data types. Now as soon as you take data, now we need to identify what is the input format. If you identify input format, your input format already defined a K1 V1. I mean key in key value for the mapper. So you don't have any control. You don't need to worry about it. Your input format is already decided. What is your key? What is your key? Key in in my terms, it is a K1. It is a K1. So you will be having a K1 V1 and K2 V2 and K3 V3. These are the input. This is input of the mapper. This is output of the mapper. Output of the mapper, and this is also input to reducer. And this is the final output. Okay, so this K1 V1 you will not be having control. It means this is predefined. It's already defined by choosing input format. Whatever the input format you choose, based on that the K1 V1 will be already decided. The K1 V1 is already decided. Okay, suppose if you take a text input format, your key is a long writable. Always see here. Why it is a long writable? Because the number, your key is a number. If you are taking a text file as input, your key is already defined. That is offset. Value is already defined. That's a complete text. So that's why your key is a long writable. Your value is a text. Okay. Now you need to design your map. The step 4 is you design map. You design map, and you need to decide what is the K2 V2, what will be the output of your mapper, what will be the output of your mapper. You need to keep in mind whatever the output you are giving from the map, that will go to input to a reducer. And so your logic has to be two phases. One is the map phase, another reducer phase. Why map phase? There will be so many mappers may launch. So when you're writing and you're designing your Mapreduce framework, you need to keep in mind that okay, there may be based on the data multiple mappers launch. If the multiple mappers launch, how the logic will be. If the single mapper launch, how the logic will be. If the multiple mappers are launched, how the logic will be. So always you have to write your map logic by keeping in mind that multiple mappers. Whenever going to design your map logic, you have to keep in mind that I'm going to write my logic for many mappers. You never know. Today you might have written for the single file. Let's assume that you have written for only 1 KB of data. So all of a sudden the 100 MB comes, your map will fail because it will not give the proper output if you design for only specific, keeping in mind that only one block. Always keep in mind that you may get a multiple blocks for your data. Okay, and fifth one, you have to decide your reducer. Your K2 V2, and finally is K3 V3. Whenever you're going to solve any problem, first you need to understand these 5 steps. Very first thing you need to do, you need to put it your design. Before going for design, you need to do all this. You need to follow all these 5 steps. You need to follow all these 5 steps. I hope everyone is clear about here till here. I hope everyone is clear till here.
Yes, sir.
Sulba, Sunil, Supreet, Adar, Anila, Masudan, Raghu.
Yes, clear.
So whenever a problem given to you, think in a bigger way, like the data may be big data. Based on that, what is the type of data? What is the input format I have to take? What is my key in? What is my value in? Then what will be my mapper output? What will be my reducer final output? And what will be in my reducer input? Keep in mind, guys, your mapper output is an input to a reducer. That's fixed. No one can change it. Your output of the mapper is input to reducer. Input to reducer. That's no one can change. That's how the framework works. Okay, your mapper output is input to reducer. The final the output of the reducer is the final output. Output of the reducer is the final output. That's fixed. Okay. I hope everyone is clear till here. Okay. So now let's look at the problem statement. Now based on that, we will design our Mapreduce framework. So my problem statement is, what is my problem statement? I need to count the number of words in a file. Let's assume that I may get 1 GB file, I may get 2 GB file, I may get so many files. I mean, so bigger, two bigger file, 1 GB file, 10 GB file, or so I may get the very big data, right? Based on that, my logic should be there. Based on my logic should be there. You should not limit yourself, or you should not limit your coding limit to 1 block or 1 block. Okay, so we think in a bigger way, and based on that you need to design a bigger way. Okay, let's look at. So as soon as you load the data in HDFS, where the data will be in as soon as you load this data will be HDFS. As soon as you load the data will be in where? In a HDFS. It is there in HDFS. I'll quickly finish this, guys. Coding we'll do tomorrow. It's already 6:30. We'll quickly finish this. So it is sample.txt. As soon as you load the data will be there in HDFS. This is my HDFS path. This is my HDFS path. So as soon as you load the data, you will be calculating the input splits. So my data here, I have only 2 blocks. Let me consider only 2 blocks. It can be 2 blocks, it can be 10 blocks, the process is same. Okay, I have blocks. block 1, block 2. The block 1, the file is divided into block 1, block 2. Now there is something called, which is not visible. These are logical. These are logical. This is physical. Okay. There is something called input format. Input format. There is something called input format. The input format based on the file, guys, not based on the block. Input format is for whole file, not for whole single block. Input format is for whole file, not for the single block. Not for the single block. It is for whole file. After input format will decide your input splits. Input splits. Input split. Your input format decides what will be my input. What will be my input split. What will be my input split. What will be my input split. So now you know the physical block, physical file, you know the format of this, and you know the input split. What is the input split? It is a logical representation of the chunk of data which will be processed by single mapper. Which will be processed by single mapper. Now I know the data has to start reading. I know my data has to read from the 0 offset to till here. I know from till here I need to read. Till here I need to read. But who will read? Someone should dare to read, no? Someone should dare to read, right? Who is the someone? That guy is called record reader. That guy is called record reader. There will be one more guy here. He's a record reader. Record reader. Record reader. There will be some guy here who is called record reader, who will decide how to read the data. Record reader. Record reader. Record reader. There is a guy who is called record reader. That guy will read your input split. That guy tells you that how to read the input split. Based on the input format, your record reader, the way of reading will change. Based on the input format, the way of calculating input split will change. The record reader also will change. If you go with the text input format, your input split is different. If you go with the text input format, your record reader is a line record reader. If you go with some other input format, the record reader is different. Okay, and from here I have my own code which I have written map. This is my map. Now my map will take a key value from the record reader. Here I have a map method. My map method will take a key value from the record reader. Key value from the record reader. My map will give some output. That output will go to short and shuffle phase. The map will go to short and shuffle phase. It is the collection of output, guys. It's not a single output. It's a collection of output. Mapper 1 output, map 2 output. Okay, map 1 output, map 2 output. That's called shuffle and sort. I'll show you what is a shuffle and sort. I'll tell you what is. Then you'll be having a reducer output. Then you'll be having a reducer. You'll be having a reducer here. This is your reducer. It will give your final output. It will give a final output. Is everyone understand the flow? How the data, these many steps are involved. Not only these steps, guys. After mapper output, here there are 3 more steps. 3 or 4 more steps are there. We'll see each and every step in the next class. Not immediately in the next class. In the coming classes, we will see what are the steps involved after mapper output before input input to reducer. Okay, this is how the map logic will works. Anyone has any doubts? Anyone has any doubt?
No, Ravi, it's clear.
Okay.
Now it's clear. Now we have to write the one program that what you have given that count, and we have to see that output.
Yes, we will write a program. Yes, we'll write a program and we'll execute it. Writing a program is very simple because
Okay.
you'll be aware of the framework. Framework is given two classes. One is a mapper class, one is a reducer class. I mean, there are other classes. I'll explain them. But the primarily mapper class, reducer. You just need to extend them. Go ahead and write your code. This is totally your programming skill. How you'll play with your programming skill. But framework is given a limited classes. If you know those limited classes, done. You are good in the Mapreduce. The only thing is how internally it's working is most important. If you know how internally it's working, what is input split, what is the record reader, if you know those things, it is pretty simple to write your Java code, or pretty simple to design the framework, Mapreduce framework. Okay, so I request you guys, everyone, please go through the Saturday class. Saturday we have discussed a little deeper. The last Saturday we have discussed a little deeper. I would request you guys go through that video. The same thing only. Yesterday what we have discussed, today what we have discussed, the same thing we have discussed on Saturday. Okay, I request you guys to go through that video.